Hi, my name's Michael Short. I'm a senior hydrogeologist working for Ecological Australia. I've been commissioned by the Northern Territory Department of Environment, Parks and Water Security to compile the final report for the water quality and quantity studies for the SREBA of the Beetaloo Subbasin. So I'll be providing just a presentation to go over those final summaries and to hopefully give a brief overview of what's in the final report for the water studies of the Beetaloo SREBA. So the SREBA water quality and quantity studies were a series of regional assessments, drilling and testing to install monitoring bores and also regional monitoring programs aimed at characterising the movement and quality of water resources overlying the Beetaloo Subbasin area. Studies have been targeted based on some of the priority knowledge gaps that were raised during the fracking inquiry, but also in the years after the fracking inquiry, when some of the geological and bioregional assessments were done, but also some internal projects and assessments by the department. So as I mentioned, there's been a few people that have looked at the Beetaloo Subbasin as far as water resources go. So following the fracking inquiry, Commonwealth agencies such as Geoscience Australia, CSIRO and the Bureau of Meteorology were involved in undertaking the geological and bioregional assessments, but also the Jazeera Research Program, which is the Gas Industry Social and Environment Research Alliance. And a lot of their work programs were aimed at addressing specific recommendations that were provided in the final report of the fracking inquiry. The other big key player in doing work for the Beetaloo Subbasin water studies was the Water Resources Division of the Department of Environment. They've been undertaking work for decades now in the region, not specifically related to the gas resources and the work and development in the Beetaloo Subbasin, but related to the water resources in that region nonetheless. And so, but since about 2018, the Water Resources Division has been undertaking specific work to address some of the key recommendations of the fracking inquiry. And I think it was in 2018 or 2019, they commissioned an independent expert panel to help develop the scope of works for the SREBA water studies. And then since that scope of work was developed, researchers from Charles Darwin University and the National Centre for Research and Training, as well as Ecological and Tetra Tech Coffee, have been providing support to Water Resources Division in making sure that the scope of work that was developed has been addressed for the SREBA. It has also been supported by some of the ongoing exploration monitoring that gas companies have been collecting for the last several years. And so that has also fed into the assessments that have been undertaken for the SREBA water quality and quantity studies. So the resources that are covered are the surface water catchments that directly overlie the Beetaloo Subbasin, and the major aquifers that have the potential to interact with the Beetaloo Subbasin, or that gas companies have the potential to interact with when they're doing their drilling and fracking processes. So over on the map over here, we have the yellow area, which is the Beetaloo Subbasin resource. That has been defined over the last few years. The red area is the general area where most of the other SREBA studies like ecology and social impact have been undertaken. And then for water resources, we have these purple areas. So the smaller area is the more focused area looking directly at the Beetaloo Subbasin area. But then we've also got a much larger area. And so the larger area covers the same area that the groundwater model developed for the area covers. So it's just to make sure that we're also incorporating model from the whole model domain. So as far as groundwater resources, so we have this map on the left. So the blue polygons that are here on this map, and also these polygons in the middle, are the really massive regional groundwater resource that covers the whole area. And so it is a series of limestone formations that go from down in the Barkly Tablelands region up around Mataranka, but also in the northern Tanami area as well. So collectively, they're known as the Cambrian Limestone Aquifer System, because parts of the aquifer do transmit groundwater across regional scales, across hundreds of kilometres. And then as far as surface water goes, we have some of the upper catchments of the Daly River, so primarily being dry river catchment on the Sturt Plateau. Then we also have some of the southern headwaters of the Roper River, so that being Western Creek, Burdham Creek, Cattle Creek, Strangways River, Arnold River. And then we have some of the Gulf of Carpentaria, so the Lim and Bight River catchments. So we have some of the headwaters of those as well, just on the very edge of the Beetaloo Subbasin area. And then probably the largest area as far as surface water goes is the Newcastle Creek and Lake Woods catchment. So it is technically part of the Victoria River Basin, but surface water within the Newcastle Creek system terminates at Lake Woods, and even though theoretically it could possibly discharge out into the Victoria River, it would take, not even in the most extreme climate, a situation where its surface water flows would actually discharge out to the Victoria River. So as far as groundwater resources go, as I mentioned, the biggest resource in the area and the most productive resource in the area is the Cambrian Limestone Aquifer System. So we just abbreviate that to the CLA, and the CLA can be broken up into two different sections. So we have the upper CLA, which is comprised of the Anthony Lagoon Formation and the Jinducken Formation, and the lower CLA that's comprised of the Gum Ridge Formation, Tyndall Limestone and Montagnini Limestone. And then besides that, we have some minor aquifers. So in some areas, the Cretaceous sediments that overlie the Cambrian Limestone Aquifer System are saturated and can host aquifers. And then underlying the CLA, we have a basalt layer that's quite widespread. There are some areas where it isn't present, but for the most part, the basalt is present underneath the CLA, almost over the whole region, and it's upwards of 200 metres thick. Then beneath the Buckalara sandstone, beneath the fractured basalt is the Buckalara sandstone. And then that's probably the last aquifer that is present before you start to get down into some of the formations that are being targeted for gas exploration. So they include the Kyalla Formation and some of the reserves that are in that, and then also the Valkyrie Formation, which is a much deeper. And so these formations are typically separated from the shallower CLA by upwards of hundreds to over 1,000 metres worth of sediment in between. And then within those formations that are targeted for gas exploration, there are a couple of aquifer sequences. So there's some minor sandstone layers like the Elliott Sandstone member, but then there's other thicker ones such as the Maroke Sandstone, which is in the Beetaloo area known to be quite a hypersaline aquifer. And then even deeper still, so but beneath the Valkyrie Formation is the Bessie Creek Sandstone, and because it's beneath the deepest exploration target, There's very, very little information about the Bessie Creek sandstone and what its properties are as far as salinity or groundwater pressures. So not too much is known about that in the area just because it's so deep. And so this map in the middle gives you a bit of an understanding of how many groundwater bores are installed in the region. So each one of these circles represents a bore that exists out in the Beetaloo Subbasin region, and the colours give an indication of which aquifer they're in. So I guess we'll start from over on the left. So these orange circles are bores that target what's called the Antrim Plateau volcanics. So that's the basalt aquifer that I mentioned. And then the different colours of blue are targeting some of the lower CLA formations. So here we have the Montegini limestone over in the Wieso Basin. Then in the Daly Basin, we have the Tyndall limestone. And then over in the Georgina Basin, we have the Gum Ridge formation. Also in the Georgina Basin, we have in the middle the Anthony Lagoon formation, which is the purple. And then a very small section where bores are known to target the shallower Cretaceous sandstone formation. So at a regional scale, we've got a selection of groundwater bores that we have collected water level information from. And from these bores, we have an idea of what the elevation surface of the water table looks like. And that gives us an indication of which direction water is flowing. So water elevations are typically higher in the southern areas, so in the Barkly Tablelands and the northern Tanami. And then groundwater levels become lower as they get towards the north. And so when they, well, towards the north, there are inferred discharge areas. So that is the Flora River. So there's a section of the Flora River where the Tyndall limestone outcrops to the stream, and there's some quite major discharge areas there. And I guess probably the more well-known ones are at the Roper River, where there's the significant springs that are just outside of Mataranka. So yeah, the groundwater level measurements that we have in the area all indicate that that's the main regional flow path for the system. And based on the geology, we also know that the regional flow path is likely broken up into two different systems. So there is a fairly extensive fault that goes almost along the same line as the Stuart Highway, sort of a little bit offset, but it kind of follows that general trend. So to the west of the Stuart Highway, there is a groundwater flow system that goes through the Montegini limestone into the Tyndall limestone as a continuous groundwater system, and it flows towards the north. And this fault called the Burdham Fault extends towards this direction, and that again sort of sections off that part of the groundwater system so that flow is directed towards the Flora River. There could be some interaction with the Tyndall limestone system of the Catherine region, but it's not really well understood at this stage. And it's thought, given how much discharge happens at the Flora River, that any interaction with the Catherine system is not likely to be that large. And then on the east of the Stuart Highway is the other major flow system. So that travels up from the Barkly region up through past the east of Larimer and up towards the north at the major discharge areas at the Roper River. This system, it's worth mentioning, is continuous with another limestone formation that goes out into Queensland. But the groundwater levels that we have indicate that at some point around where the Barkly Highway intersects with the Tablelands Highway is that there's what's called a groundwater flow divide, where on one side you have flow that goes up towards the Barkly Tablelands, and then on the other side you have eastward flow that goes off into the Queensland flow system that goes out to the Gregory River. But the other thing that's worth mentioning as well is that even though the flow system has been inferred based on these water levels to go from the southern areas to the north, The volumes of groundwater discharge that occur at the Roper River and the Flora River each year roughly equates to how much recharge is estimated to occur just in the very local areas around those discharge sites. So even though there is some general groundwater flow from the south, most of the discharge that happens at Flora River and Roper River is sourced from the very local area. And that makes sense just given how much more rainfall there is in these northern areas, and also how thinner the surface cover is on the aquifers, with greater potential for recharge in these northern areas as well. So it's only likely that there's a decent amount of flow coming up from these southern areas when either the monsoon fails or there's just very little recharge during the wet season up in the north. So this is just a cross-section view, so won't spend too much time looking at this, but yeah, this just gives the general idea. So we've got a cross-section through the Georgina side, so the Roper River flow path. And as I mentioned, you've got in the middle Anthony Lagoon, so the upper CLA, and the Gum Ridge Formation, which is the lower CLA. And it's inferred that groundwater slowly flows through those formations. Connects with the Tyndall limestone, which is just a different name for the same sequence as the Gum Ridge Formation, and then flows out towards the Roper River and Elsie Creek. And then on the western side, so the Wheezo Basin side, you have a similar situation. You don't have any upper CLA present in on the western side, just because everything's kind of been raised up, and the upper CLA, if it was present, it's been weathered away, so it doesn't exist anymore. So all of the flow occurs through the lower CLA, which is the Montagini limestone, into the Tyndall limestone, and then out to the Flora River. And as I mentioned before, is Kalkarinji Sweet, which is yet another name for the basalt. So it's sort of interchangeably called the Kalkarinji Sweet, the Antrim Plateau volcanics. So they're the geological names. But typically within the area, it's just referred to as the basalt. And then this is a similar map to what I showed before, but rather than groundwater elevations, this shows depth to groundwater. So these dark blue areas are where it's 90 or 100 meters plus to get to the water table. And then in areas where you've got yellow, it's where the water table is either really close to the surface or less than 15 meters. So that's typically around the Flora River, where we know there's discharge, and the Roper River, but also Elsie Creek, where there's some swamps and discharge sites there as well. But also during this work, we've put in a couple more bores and got a bit more information about the area around Top Springs, where, given its name, we know there's a few springs around there that are sourced from limestone. And as we found through some of the monitoring during this work, there's also quite shallow water levels there as well. And so given that the limestone outcrops here, it's also inferred to be a recharge area as well. So you're likely got just a very local system here where you've got recharge during the wet season, and particularly during the current wet season of 2022, 2023, where Top Springs and this area in general has got quite a bit of rainfall. During those types of years, the limestone around Top Springs is likely to be recharged. Some of that may find its way into the regional system, but some of it will also be discharged at the springs that are known to occur around this area. The other areas where there's shallower water levels are beneath the Barkley Lakes. So that's Tarrable Lake, Corella Lake, Lake Sylvester, and Lake de Burr. The water levels are known to be a bit shallower there just because there's a bit lower topography in the landscape around those areas. They're also believed to be potential recharge areas as well for the underlying aquifer. So across the region, there's a few different potential recharge mechanisms. So in most groundwater systems, diffuse recharge is always a possibility. So that's where you've just got fairly gradual diffuse infiltration of rainwater through the soil profile and the unsaturated zone, and it reaches the water table. And so, as I mentioned here, that occurs to some degree across the entire region. And then there's another one that's kind of similar, but it's a bit more rapid. So that's macropore recharge. Again, that occurs through the soil profile. So where you've got larger cracks or small features like old root casts within the soil profile, where water can kind of bypass the more diffuse flow through the soil and rapidly travel through the soil profile in an unsaturated zone. And again, it's likely to occur to some degree over the entire region. Then we come down to, I guess, the more discrete types of recharge. So it's point source recharge. So it's believed in the area, because we're dealing with limestone formations, karstic features like sinkholes are quite common in the northern areas where the limestone outcrops to the surface. So that's around the Flora area and the Mataranka area. And so these sinkhole features act as point or focuses of point surface water flow, where there's essentially a direct connection between surface water and groundwater when there is flooding into the sinkholes. But sinkholes are also known to occur throughout the Sturt Plateau region and the southern areas, where the limestone is covered by a thick sequence of Cretaceous sediments. So while these are sinkholes, they're not necessarily related to limestone, like I guess what people classically think as sinkholes associated with limestone dissolution. So these features are related to, they're termed laterite sinkholes. And so they're nonetheless, potential focuses for surface water runoff when those areas do flood. And because they're focus points for that surface water flow, surface water tends to hang around a little bit longer in those areas, and that just increases the potential for recharge to occur to the underlying aquifers, even if the water level is deeper and there's a thicker layer of sediments in between the surface and the underlying aquifer. So some areas where those sinkholes are quite common around the Dry River and Western Creek area, and also in the Newcastle Creek headwaters as well. The other one that can occur, but it's probably the more minor recharge mechanism in the area, is called mountain front recharge. So down near Elliott and the southern areas of the Cambrian limestone aquifer system is the Ashburton Range. So surface water that runs off during the wet season from that will quickly run off down the sides of that mountain range and go into some of the creek flood out areas at the base of that mountain front. And it's at those areas that there's a higher potential for surface water to sort of pool at certain stages and then infiltrate into the underlying groundwater. And the Ashburton Range is not a significant feature in the landscape. It's not regionally extensive. It's only really extensive down in the southern areas of the Cambrian limestone aquifer system. So this mountain front recharge mechanism isn't really thought to be that important for the water balance of the system. And so those were the recharge mechanisms. So the recharge areas, the primary recharge area is the monsoonal rainfall areas. It's a combination of these top two. So it's the monsoonal rainfall areas, which are towards the north, but that also coincides with where there's a lot of limestone outcrop. So that's around the Mataranka and Flora areas. But there is potential to have limestone outcrop in the areas around Top Springs and some of the other basin margins to also be areas where recharge is more likely to happen if there's rainfall during certain years in those areas. And again, just to sort of go over it again, the sinkholes around the Mataranka and Flora areas, but also in the Sturt Plateau. And one of the lesser known recharge mechanisms is the last one. So it's around some of these really significant inundated areas that only episodically fill. So Lake Woods and the Barkley Lakes. So they are mostly dry in the region, except for years like the one just passed, so the 2022-2023 wet season, where Lake Woods and the Barkley Lakes have actually had surface water in them. And so most of that surface water will just go on to evaporate, but some of it does infiltrate down into the groundwater below. So there's been a few studies that have supported the work of the SREBA that have shown that they are likely to be recharge areas when they do get flooded. So I guess just to go more into recharge, so across the study area, there's three primary groundwater level responses to that recharge. So in the northern area, you have this really classic wet season type water level response where over the wet season months, and especially when there's monsoonal periods, you get a spike in groundwater. And then once that wet season and monsoon subsides, there's a gradual decrease. And this decrease in water levels is due to discharge to surface water features and evaporation when it's being used by vegetation that has roots that can access the groundwater. But also there's a component of groundwater extraction as well. So there is groundwater extraction around Mataranka. So some component of this decline is due to that as well. But it's mostly due just to the natural cycle of filling up during the wet season and then discharging to the river during the dry season. And as you can see, these blue columns are the rainfall totals for the wet season. And so the strength and the amount that the groundwater rises in these areas is very much related to how strong the wet season is and how strong the monsoon is. The second type of response is as you go a little bit further south. So this is the episodic recharge areas, and especially with this water level trend where you see mostly flat lines, but then every now and then you get a year where it spikes and then sort of starts to recede. This particular bore is in an area around some known sinkholes, and so this is likely to be the response that you get when you get recharge through point features like sinkholes. So especially when you have enough rainfall to cause surface water runoff, you'll get flow into the sinkholes and you'll get a spike in the groundwater levels as the water recharges. And then similar to the seasonal recharge areas, those groundwater levels subside, but the reduction in these groundwater levels is not due to direct surface water discharge like it is towards the north around the rivers. This reduction in groundwater after that initial spike is because this is very localized recharge, and so you get a bit of a groundwater mound, and then over the next few years that groundwater mound and pressure will just start to dissipate into the aquifer unless another recharge event occurs. And then over long periods, so this period here is the very dry period that we had during 2018, 2019 and 2020. So during those dry periods, as I mentioned earlier in the presentation, that's when you start to get a bit more of the flow from the southern areas up towards the north. And because of that, you get a groundwater decline in the southern areas as that water moves to the north. But another thing that you can see in this water level record is that over the last 20 or so years, that groundwater levels across the Sturt Plateau have actually increased by about 5 metres. And that a similar response is seen in a handful of the other monitoring bores that the department has. And then probably the last type of response that we've categorised out in this area is what we've termed as gradual storage change. And so it's kind of almost code for just sort of saying that you don't really have much groundwater change at all. So if you notice the groundwater level range on the y-axis, it's much smaller than the others. And so, and you can also see a lot more noise in this, and it's just because it's zoomed in a bit more. So this is at a site that's close to Dunmurra along the Stewart Highway. So it gives you an idea, it's a bit further south in the system. And yeah, there's been very little change since about 2015 when monitoring at this site was established. So this little spike here was when a pumping test was undertaken. So yeah, it's produced the biggest response that this bore has seen. Besides that, it's been just a very gradual increase in water levels over the last few years. And I've kind of touched on this already, just with describing the system in general. But there's 3 main discharge mechanisms that are known to occur across the region. So that's river base flow, so up at Flora River and also Elsie Creek and Roper River. And that's where the aquifer has been incised by the watercourse, and you've got direct discharge of groundwater into the streams. And yeah, it's in those areas that dry season flows in those rivers are actually maintained entirely by groundwater flows. Then related to that, but a little bit different. So these are discrete springs. So they're probably more well known in the Mataranka area, where you've got a series of springs just outside Mataranka that you can visit and swim in. So they're discrete features where you've got a point discharge, which discharges to the surface, but then also flows down into the river. And there is a few discrete springs that are also known along the Flora River, but yeah, they're less well known just because it's less accessible out in that area. The other main discharge mechanism is through evapotranspiration. So evapotranspiration occurs across the region. So even in the southern areas, there is evapotranspiration, but it needs to be distinguished that the evapotranspiration, so the evaporation due to use by terrestrial vegetation in the southern areas is purely just from rainwater falling and then being taken up by the plants from the soil water. Because the groundwater levels out in those southern areas are too deep for any trees to access and use. It's only once you start to get, I guess, probably north of Larimer and west of the Victoria Highway that the groundwater levels are shallow enough to the surface that terrestrial vegetation can actually access groundwater. And it's in those areas that groundwater can actually be discharged by vegetation. And once groundwater levels get even shallower still, so within a couple meters of the surface, of the ground surface, you can actually even get direct evaporation of the water table. So it doesn't even take plants to evaporate the water. It can be just direct, just due to the solar radiation and how warm the ground is up in these areas. So the discharge areas, again, been over this a few times, but this is just a map to kind of really highlight it. So I'll go over the discharge areas for the Cambrian limestone aquifer. So as I mentioned, so Flora River discharge area. So you've got discharge at both springs, but also directly to the river channel. And then quite a few of the springs are actually located within the river channel itself. Whereas at the Roper River, you have river discharge, you have discharge along swampy areas like Elsie Creek and Warlock Waterhole. But you've also got the point discharge of some of the well-known springs in that area too. Then over at Top Springs, as I mentioned, there's a local groundwater flow system that is recharged locally and also discharged locally, and some of that flow is likely also to join up with the regional flow path that goes up to the Flora River. The one that I haven't mentioned until now is Hot Springs Valley. So this is a series of springs to the north of the Cambrian limestone aquifer. So it's not part of the Cambrian limestone aquifer. But they are some deep sourced, fresh, and quite hot, comparably to the springs of the rest of the Northern Territory. Springs that occur along Lagoon and Beauty Creek, which flow up into the Limmenbight River. And so, as I mentioned, these springs are quite unique because we had some field crews out there recently and measured temperatures of one of these springs up to about 65 degrees. So that's warmer than any other spring that's known to occur in the Northern Territory. And the reason for this is that it comes from quite deep. So in this area, there's also known to be a fairly extensive regional fault that is likely to have facilitated a direct conduit for flow from some of the deeper aquifers. So again, it's not from the Cambrian limestone aquifer, it's from a deeper system. And so we have some indications of which formation it's from just based on the temperature of the discharging groundwater. And so it is potentially some of the deep Proterozoic rocks that further towards the south where they are deeper are some of the formations that the gas industry are drilling into. So it's definitely an area for some future investigations. Water quality of the region has been studied quite extensively. So both specifically for investigations relating to the Beetaloo Subbasin developments, but also just generally because groundwater investigations in this area have been going on for decades now. So this map over to the left gives an indication of which bores and how many bores we have groundwater quality data for. So a lot of these are from landholder submitted results for water quality, but there's also quite a lot. So the black dots during a research program from Geoscience Australia, the pink ones are from CSIRO, the white the petroleum industry, and then we've also been provided with some of the extensive water quality sampling that gets undertaken at the bore fields for town water supply of Mataranka, Larimer, Daly Waters, Newcastle Waters, and also Elliot. So the most covered aquifer for water quality data is the upper and lower Cambrian limestone aquifer system, just because it is the most widely used. So it sort of makes sense that we have the most data for that resource. The next in line, and again, it makes sense because these are the next in line when it comes to how much they are used in the area, is the basalt and the Cretaceous aquifers. But we also have some limited data for the Buccalara sandstone because in areas where it's shallow, such as over on the Sturt Plateau, so on the western side of the Stewart Highway, there are some stock bores that go into that, but there's also some bores that are monitored by the petroleum industry over towards the east as well, where we have data. So just going to show in the next few slides some of the regional water quality for the region. So on the left-hand side, we have salinity of the Cambrian limestone aquifer system. So the blues show where it's less than 500 milligrams per litre, so that's classified as quite fresh. And so you'll see that it's typically fresher on the western side. So in the Tyndall limestone and Montegini limestone, there's a section that's along the Stewart Highway that's a little bit higher. But then, yeah, towards the northern Georgina and into the Daly Basin and towards the Roper River, it also freshens up as well, just because there's likely to be more recharge in those areas. And then, so towards the southeast, where some of these bores are more likely to be in the upper CLA. So the upper CLA is known to have more variable water quality. And the reason for that is that just some of the rocks within that upper CLA sequence are known to dissolve things like sulfate and just other salts into the groundwater. So typically where that's present and where bores go into it, you've just got a little worse water quality than you do in the lower CLA formations. And that's quite apparent when you look at the proportion of sulfate across the region. So as I mentioned, where you've got the upper CLA, the proportion of sulfate compared to other dissolved constituents is much greater. There's also some small sections of that upper CLA over in this area, which is near the OT Downs subbasin, so it's a bit of a depression where you do have a sequence of the upper CLA as well. And then also up towards the Daly Basin, so you have another equivalent of the upper CLA formation called the Jindukin Formation, and that's where this little hotspot of sulfate is up here. They're bores that target, rather than the Tyndall limestone, they're targeting the Jindukin Formation. So sulfate is quite a good indicator, and another reason why we know that these two sides of the Stewart Highway are segmented into different flow systems, because you can see on the western side that sulfate proportions are typically quite low and water qualities are quite fresh, where there is a very stark contrast to the eastern side where sulfate proportions are fairly consistently higher than on the west. And then as far as things that are more related to the petroleum industry, and I guess some of the constituents that people out in this region are more concerned with as far as their water quality goes. On the left-hand side, we've got a map of where we have sampled, or not just the department, but also the industry and some other studies have sampled for dissolved methane in groundwater. So you'll see that it's mostly pretty low across the region, but there have been instances and multiple instances in some cases at some bores where methane at low concentrations is quite commonly observed. So, and it's not really got much of a pattern to it. So during some of the work after the fracking inquiry, they also measured carbon isotopes of the methane that was dissolved in the groundwater, and they found that most of the carbon, or most of the methane, dissolved in groundwater is actually related to microbial activity, either within the shallow aquifer, or probably more likely it's to do with microbial growth within the bores itself, because throughout the area, throughout a lot of groundwater systems, things like iron reducing bacteria, or iron bacteria and sulfate reducing bacteria are quite common, and just through their activity and decay in the boreholes themselves leads to the production of methane. And another line of evidence for that is dissolved ethane. So in a lot of areas, and especially over the last few years when it's become more commonplace out in the Beetaloo area, dissolved ethane is also measured at the same time as dissolved methane. So microbial activity more likely leads to methane, whereas the gas reserves of the Beetaloo subbasin are known to contain a decent proportion of ethane. So if you also get observations of ethane, that's when you're going to start to potentially see that that gas, that dissolved gas, is actually got a deeper source. And so what you can see is that all measurements of dissolved ethane across the Beetaloo Basin so far have been below detection. And so it's just another line of evidence that indicates that most of the methane that we've found in bores across the Beetaloo subbasin area is actually due to microbial activity. But that's good to know, because it is a good thing to understand that ethane is likely to be a good measurement criteria going forward, where it can determine and distinguish between where it's just naturally occurring microbial activity within boreholes that is fairly mundane, versus where if you start to see ethane and seeing connection with potentially loss of integrity at petroleum well exploration sites and operation sites. And then the final section of the work relating to the SREBA Water Studies as far as groundwater goes is the groundwater flow model. So this is the tool that gets used by the department and Water Resources Division to simulate the groundwater system, to understand both just natural flow systems and the natural water balance, but also to simulate things like groundwater extraction when licenses for that extraction come in. They'll be able to test it and to see how the aquifer will respond. So the groundwater flow model for the region is quite mature. So it was originally developed in 2008, 2009 for the Ulu Dolostone, which is further to the north and outside of the study area, and it doesn't interact with the Beetaloo subbasin. So that was developed during the Gulf Water Study. The model was then further developed as part of the Northern Australia Sustainable Yields Project, which had some focuses on the Daly River and the Roper River. And during that time, it's been peer reviewed twice to make sure that the development and use of the model aligns with industry standards. The last update was in 2018 following the fracking inquiry. The model domain was increased quite drastically. So it was increased to encapsulate all of the Beetaloo subbasin and even further. But it was also the model mesh. So sort of the resolution of the model was made finer directly in some of the exploration leases around the Beetaloo subbasin as well, just for future assessments. So the current model is called the Daly Roper 2 or the DR2 model, and that's because it not only models the groundwater system of the CLA, but it also models where it is connected to the Daly River at Flora River, and also along the Daly River itself, and also the Roper River. So the next step for this is to actually upgrade it to the DR3 model, which will be in 2023 is when it's scheduled. Parts of that update have already occurred where the data was ready. So it'll be peer-reviewed once it's updated in 2023, and it will incorporate all of the findings from the SREBA work. So some of the ongoing priorities for groundwater resources in the area are to continue monitoring and to assess the interconnectivity of some of the shallow groundwater systems, but also the connectivity between the shallow groundwater systems and the deeper systems that are more associated with the petroleum industry and their activities. And so there have been some indications across the area that there might be a minor connection between the really deep aquifers and some of the shallow ones. But it's not really well understood. But CSIRO have provided some really good information on the best likely areas to investigate those processes and some of the areas where that connection has a higher potential. Another one for a future priority is to investigate the water supply potential of aquifers that have less public use than the CLA. So the CLA is quite a high value and competitive resource. So there's some aquifers out there, such as the Bacalhau sandstone, that might be, well, its salinity and quality is too poor to be used for things such as pastoral use and town water supply. It might have the ability to be incorporated into some of the petroleum activities. And I think through the Beetaloo Subbasin projects, the influence of sinkholes across the region has definitely been highlighted as far as recharge mechanisms go, and also as far as it relates to rapid recharge as well. So related to things like surface contamination and the potential for that to actually get into the aquifer, better mapping of sinkholes, and direct recharge features like them are definitely something that will need to be improved for the future. And as I mentioned in the water quality, a broadening of an understanding and sampling for things like hydrocarbon gases, methane and ethane. So as we've found over the last few years, it's quite common to observe dissolved methane in bores in the area. But that information is almost a bit meaningless if it's not also combined with measurements of other dissolved gases that would be expected to be present if it was sourced from some of the deeper formations. And so that's things like ethane and propane, which are known to occur within the gas deposits of the Beetaloo Subbasin, but are less likely to be present if it's just related to microbial growth. And then probably the one thing that will come of all of this work and the much better understanding of groundwater resources that is now present for the area is to update the groundwater monitoring components of the code of practice for the onshore petroleum industry in the Northern Territory. So the second component of the SREBA Water Studies was the surface water resources. So as I briefly covered off in one of the earlier slides, so the drainage divisions that are covered that overlie the Beetaloo Subbasin include the Tanami Timor Sea Coast Drainage Division and the Carpentaria Coast Drainage Division. So we've got the Daly River, which is a tributary, the Dry River, which is a tributary of the Daly River. And then we have a couple of tributaries and catchments that are considered part of the Victoria River Wheezo catchment. And then towards the north and also to the east, we have the Carpentaria Coast catchments, which include the Roper River, the Limon Bight River, and the MacArthur River. So the flow characteristics across the Beetaloo Subbasin, most of the surface water systems are ephemeral, with flows only occurring during the wet season. The exception to that is at the discharge areas that are towards the north of the Beetaloo sub-basin. So that's the areas where there's groundwater discharge and surface water flows are maintained throughout the dry season through groundwater. In the southern areas, there's episodic flows due to the area being more arid and less influenced by the North Australia monsoon. And we've been using some of the satellite imagery in the area to reconstruct some of surface water flows, but especially when these flood out areas, lakes and swamps become inundated, because it's likely to give an indication of when recharge is occurring down in these southern areas. And so just on the left here is just an example of that, of a period back in 2016 when Lake Woods was full, and then through to when it evaporated down to dryness. And so another thing to notice here is that while Longreach Waterhole doesn't flow perennially, it does typically have surface water within it perennially. So Longreach Waterhole rarely dries out completely, and I'm not too sure if it's actually been known to dry out completely, because it usually has some water in it, but it's usually standing water, not flowing. So as I mentioned previously, during the 2022-2023 wet season, the Barkly and Tanami area has received quite a lot of rainfall, especially during the period where ex-cyclone Ellie was present through the system and was dropping quite a lot of rain. So these are just some satellite images using the Sentinel satellite, and the imagery that I'm showing here is the shortwave infrared band of that satellite. And so shortwave infrared just highlights open water a little bit, so it is a bit more obvious to see. So that's these blue areas. So as you can see, Lake Woods has filled a little bit. I've looked at some images after this, and it seems to not have really got much larger in size than what it is in this image, because there's not been enough rainfall to keep sustaining it, and it's actually been quite warm out there. So some of that water's evaporated from Lake Woods as well. But Lake Sylvester is still quite full. So this is a fairly recent photo in late January. And some of the recent photos also show that, Lake Sylvester is still quite full. But then you've also got the Eva Downs and the Tarrable Lake system, which got a little bit of water, but a bit less than compared to the rest of them. So the region has been quite wet, and so some of the new monitoring that has been established in the region, we have time series high resolution groundwater levels being monitored out near some of these large lakes, and so it'll be interesting to see the data come in from that to see if we do see any evidence of recharge from these large flood out areas. So as far as water quality goes, there's not all that much data for the area, because as I mentioned in the slide just previously, the surface water flow in the area is ephemeral. So it's basically, there's only been a few studies in the area where surface water has been present and it's been sampled. So luckily during some of the years of the SREBA Water Studies and ecology studies, there's been some water out in these regions. So it's been sampled as part of that. When some of the swamps and lagoons and lakes have been visited. So the general trend, so the northern sites typically have water quality that's similar to the Cambrian limestone aquifer because that's their source. The turbidity is quite low, and so I think people will probably know from pictures of some of these rivers where during the dry season, the water of the Flora and Roper River is that really crystal clear blue colour, and that's due to it being filtered through the limestone and groundwater discharge. By comparison, the southern sites have a very variable water quality. So some sites are almost like rainwater, and other sites are getting towards brackish and saline. But it's also a lot more turbid, just because it's when these areas get flooded and a lot of the dirt and clay particles and soil gets mixed up. So yeah, they're quite cloudy. Um, and yeah, quite high also in nutrients and algal activity as well. So similar to the groundwater system, some surface water models have been developed for the area. So the ones that I'll talk about are the ones that are not connected to groundwater. So that's the Barkley Lake system. So a surface water or a rainfall runoff model has been developed for that system, covering quite a large area. And it's collectively known as the Barkley Basin rainfall runoff model. And then the other one is the Newcastle Creek Lake Woods system. So again, not connected to the groundwater, and it's a internally draining catchment that has no outlet besides Lake Woods. And then, as I've mentioned previously, we also have the model that's developed for the Roper River and Daly River, which is combined with the groundwater model of the Cambrian limestone aquifer system. So as far as ongoing priorities for surface water resources, it's likely that a lot of the gas industry projects out in this region will need project-specific flood mapping, because from what we've seen and what we know about the area, there's quite large flood areas across the Beetaloo area that may pose flood risks to infrastructure. But there's also a risk of things like roads and pipelines actually modifying some of the flow paths, for these flood out areas and the catchments out in the Beetaloo subbasin. And again, similar to the groundwater resource, sinkholes are likely to be quite important, and knowing where they are. So continued mapping of those features, and also just smaller water holes is likely going to be an important part of ongoing environmental monitoring for the gas development projects in the Beetaloo. So similar to the groundwater baselines or groundwater quality baselines, it will be important that projects develop surface water quality baselines. And given that a lot of surface water flow in the area is ephemeral, it's likely to also need to incorporate sediment quality of key water courses in the area as well, because it's not always going to be feasible to actually sample surface water itself. So sediments within those water courses can be used as a proxy for if things are changing over time. And another useful thing that will need to be incorporated into the future, which currently isn't incorporated, is having a provision to include surface water monitoring. So both quantity, so that's things like stream gauging, and undertaking tasks like flood mapping and surface water modelling, but also, as I mentioned, things like surface water quality and sediment quality, and incorporating those things into the code of practice for onshore gas activities for the Northern Territory. So the work that I've just given you a presentation on has had quite a few outputs. So some of the really things worth highlighting is that the Department and Water Resources Division have installed 23 new groundwater monitoring bores, and that's in addition to the existing network of bores that has been established up around Mataranka, Catherine and the Flora River. And there was also a few existing groundwater bores down towards the Barkley Tablelands, so the Barkley Highway and the Tablelands Highway. And so they have been re-established as monitoring sites after not being monitored for quite a few years now. So the work that I presented on has been detailed in 16 different technical reports, and so they're just the technical reports that have been commissioned over the last couple of years as part of the SREBA works. That doesn't include things like technical reports produced as part of the geological and bioregional assessments or the Jazeera program. And so all of that has led to what's been synthesised through the SREBA Water Studies summary report. And all of the key data sets that you've seen today will become public on either NR maps or the SREBA data catalogue. And then the other thing that I haven't touched on yet, but the technical work that has been part of the SREBA Water Studies, it will form the technical and scientific basis for the draft water allocation plans that are currently being proposed for the Georgina and Wieso area, but also for the water allocation plans for the Mataranka and the Flora area as well. So for such a large program of works like the SREBA, and this is only even just talking about the water studies, there is quite a few different people to thank. So first and foremost, I'd like to thank the traditional owners and all of the different traditional owners and native title organisations out in the Beetaloo area. So that's include Nordalingi, the Aboriginal Areas Protection Authority and the Northern Land Council. So they have all helped to provide advice or facilitate engagement of First Nations people to make sure that we had approval to do work in some of the areas that have been monitored during the SREBA Water Studies. Thanks to landholders as well out in the area who've allowed access to their properties for monitoring and in some cases installation of things like monitoring boards. Other NT agencies like Roads Division, NT Parks, the Geological Survey and Power Water Corporation have each provided help in access to land, like Roads Division in installing some monitoring boards along the road corridors, NT Parks for allowing installation of some monitoring boards within some of the parks up around Elsie. Geological Survey of NT has provided advice as far as conceptualising the groundwater system and the different formations that it's made up of. And Power and Water Corporation have provided an extensive database for water quality from some of the township borefields. We've also had some contractors help us, so Charles Darwin University and the National Centre for Groundwater Research and Training have provided key inputs and technical work into the SREBA Water Studies as well. And the final summary report was reviewed by a couple of the members of the expert panel of the fracking inquiry. So we thank Barry Hart and David Jones for providing that feedback on the final report. So thank you. It's a lot to cover, and the technical reports and the final summary report go into what I've discussed in a lot more detail. And yeah, it's quite a lot of work, and it's been quite impressive to see it all come together. So I'll leave it there.